So in this video, what we're going to look at is finding the traces of an oblique plane when you're given the angle or the inclination of that oblique plane to the horizontal plane, okay? And also given points on that plane. So what you have here is you have the points A, B, so you have A and B, and you have A and B. So you'll see it, you get the information for it over in this one. And it says that it wants us to find a trace of the oblique plane that contains AB and is inclined at 70 degrees to the horizontal plane. Okay, so the information that we're given is that we're given our A, we're given our B in our two views, and then what we're asked to do is to find the traces knowing that the oblique plane is inclined at 70 degrees. Now, to do that, there will be a number of ways to do this, but the easiest way is to use cones. And this comes back to something that I said to you when we were looking at solids in contact, and that is that cones are a very useful tool for solving a lot of problems. Okay. Now, the way to think about this is that if you were to imagine having a plane sitting on the ground, and if you had it resting up against your cone, okay, so if I use this as an example, if you had your plane sitting up against the side of this cone, and let's just say that we're looking directly in at it at the edge view, if it was sitting against the cone, the angle to the horizontal plane would be 70 degrees, okay? Because if it's sitting up against the cone, it's going to have to touch the bottom of the cone, and it's going to have to touch the apex of the cone for it to be actually touching it and resting up against it. So if you have a plane resting up against the cone, then it's going to be at the angle of the base angle of the cone. Okay. Now what we can do is we can use that to solve these type of questions by just saying, if I have 2 points and I know that the angle of the plane, so the inclination of the plane is 70 degrees, I can draw two 70-degree cones from those points. So what happens is that if I draw, and you'll see that what they've done here is that if you have one cone, so from A, and then you have a second cone from B, both with an angle of 70 degrees, you know then that if you put a plane up against the first cone and the second cone, so it's just resting up against the two of them, it has to be at 70 degrees. Okay. Now the reason that both are 70 is because that's what the oblique plane is inclined at. Okay, so I have two cones at 70 degrees. What happens then from there then is that it's just projected down from, so if I was to put in a horizontal line across here, which there should be in this, and one going across here, just because you need something to project to. What it would be doing is projecting down from this side and projecting down from here to find then the radius of the base of that cone. Okay, so you have the base of the cone here and you have the base of the second cone over here. So that's the cone sitting at A, that's the cone sitting at B. And we know that a cone will look like our triangle in our elevation, which means that it's going to look like a circle in our plan. All we have to do then to find the traces, that we know that if it's sitting up against the cone, okay, we know that it's going to touch the base of both. So if it's touching one, it's going to touch the base. If it's touching the other one, it's going to touch the base. So what we can do is we have then the horizontal trace because of where our cones are. So if we go tangential to this cone and to this cone, then we know that because the bases of both cones are on the ground, the horizontal trace is going to be touching both of those. Now there is a construction for finding the tangent to, or a tangent to two circles, but in this case we don't need to use that construction. We can just do it by using your set squares. Okay. Once you then have your horizontal trace, then finding your vertical trace is the same thing as we would have done before when we were looking for vertical trace. So if you had, and you can see they've done it here, so they've just taken it from A here, so they've gone from A parallel to the horizontal trace, then where that hit the XY line they've gone straight up, and then they've gone corresponding from A then across to find then in there your vertical trace. So again, the most important thing about this is that you understand that if you have a plane that's sitting up against the cone, then it's going to be at whatever the base angle of the cone is at, okay? And we can use that information and that fact to then be able to go the other way around to be able to draw the cone at its angle first from 2 points, and then finding the horizontal trace and then finding the vertical trace. The important thing to remember in this is that to be able to use this method, you need to have 2 points, okay? You could have 3, 4, or 5 points, but you'll have to have at least 2. Okay, for to be able to use this method to find the traces of the plane.